Thank you, Janet. So, guys, I hope that you have had the time to have a look at the case study. So I've seen now that one group has uploaded the current state, so some of the work done. And do you want to any of the group want to share what has been the consideration of the fish plate for the first for the current state? So an analysis of the current assembly. So then we can collect some information and share with the groups, and then we can plan ahead what might be an implementation for the future improvement.
I think Graham, you're doing a wee second, Adelaide.
Yes, no rush. Also, in the meantime, you can also, if you have any question, anything, we can discuss, and then I think it would be nice if we start with some consideration, and then the other group can at the same time come up with some consideration, even if they have not submitted, but maybe there are something work in progress, so we can at least list for the two assembly, fish plate 1 and fish plate 2, some consideration, and then what might be the future states, future consideration based on the application of one method or simple consideration of the guidelines of the FMA.
Adelaide, I mean, if no one else is stepping forward, group 4, we've put some slides together with some, thoughts and queries and stuff like that. We can share if
yes, please.
That'd be good for the group. Okay. So morning everyone. It's Scott. So part of group 4. Morning. Part of group 4 along with Rob Fitzpatrick, Archie, and Jason. So for a couple of sessions, just sort of knocking some ideas around, and we've got some things that we think we need to, some questions we need to ask just to clarify a few things, and perhaps help us, get a good get a good analysis. So we've put together a bit of a pack of slides, and we're going to take a little turn each at presenting a couple of the slides, and hopefully it'll get a bit of discussion going, and maybe we can sort of highlight and answer some of the queries that we have. If that's okay.
Yeah.
So we noticed that the brief that you put on the course site. So so as we understand that by Saturday we're looking to have assessed the overall assembly current state and the fish plate assembly current state, if I understand. So and from last week we spoke about either focusing on sort of one side of the assembly or the other instead of the entire assembly. That's correct, yeah. So
yeah, correct.
So there's two different types of fish plates. So we can either focus on the left hand side of the image as we see where got fish plate 1, I think it was, from the brief, or on the right hand side fish plate 2. I'll hand over to Jason. Jason's going to just talk about the sort of the bill of materials and the exploded view.
Thanks very much, Scott. Morning all. Basically what it was is we started to look at the bill of materials. We were trying to identify the items from the top level assembly bill of materials against the drawing. And again, we tried to match it as best we could. Like I said, item 1 with the walkway, again, we've marked that down there as well. But as we started to go through it, we found like some difficulties. Like again, some of the weights were missing and some of the information on it. Again, item number 4, which was, we believed it to be the pipes on the top part of it, but again, it's just to try and get some clarification. Was that the actual pipes? Because there's no actual occurrence name on it. It looks like just an occurrence number. And again, in the lower level one, we tried to have a look into that as well. Also, again, is we had the exact same issue in item 14. Again, it's just the occurrence number and not the occurrence actual name to identify against what it was, because as we went through going through them all to identify them, we weren't too sure what this item was. Again, in the blown up view of it, you can see we've got a question mark there. So again, it's trying to find that information, what could it actually be, and also some of the missing weights as well. You go to the next slide, please, Scott. So again, we had a look at the fish plate as well and identified that. Let's say that was item 10 in the bill of materials. And again, looking at the drawing, we knew it was made from DH36 material. And again, the sizes are in there as well. But again, in the actual bill of materials, that information is not properly there. It just says the fish plate. So again, it's having to go elsewhere to get that proper information to see what it actually is as well. So what we also done as well is just looked at the process and tried to match it to the material as well. So again, current design build steps, and again we've got like the cut plate, which is the fish plate. Then we drill the flange holes, and then we drill the base plate holes. And again, looking at this, it's done in the shop. Then on the ship part, it's like step 4 is take it to the shop, the ship, sorry, and then step 5, cut the green material off. Then we tack weld it, and then step 7 is remove it from the ship. Then we go back to the shop again, and we conduct the fully weld it, do the paint, the fish plate, and take back to the ship. And then step 11 is we drill the ship seats, paint the seat, and then we bolt the base plate and the flange. And again, this happens at the ship. So kind of query we had is only the fish plate is included in the build steps until the final steps. No detail on how each step performed, making a assessment difficult. Some parts and several steps do not suit sequential DFA analysis. Seems to be more about manufacturing sequence and lean efficiency. And again, this is like some of the queries we had on this. So as you can see, a lot of the steps really are going to the bill of material part really for the fish plate itself. You just come out, like I said, the last parts, so like for 11 and 10 on that as well. So again, it's quite a few wee queries still on this. And again, it's like only seemed to be half the information was there. We looked, tried to find more information, and we couldn't really find it. So again, it's something for us to discuss as well. So on to the next slide. And who's covering this one?
I think it's me, Jason. So yeah, we found it really difficult to associate. I don't know if the other groups found the same thing. Really difficult to associate the bill of materials to the exploded view, and then the build sequence didn't include assembly of a lot of the main items in the big assembly. It really just focused on bring your fish plate in, cut your green, take your fish plate back, finish it, and bring it back again. So it's more about the flow of parts than the actual physical assembly of one part to another. So I don't know if other groups experienced the same.
We were the same as well. There seemed to be quite a few gaps, and it didn't seem as straightforward as perhaps it should have been in terms of listing the full bill of material in the sequence.
Yeah,
definitely. I mean, like a quiz.
yes, a puzzle.
Fill in the blanks. It's like a fish plate Sudoku.
Yeah, but I think this was also one of the scope of the exercise of the case study. So maybe before, without knowing the DFMA or the principle, what those missing information wouldn't come out. So applying the methods, then you realize that the information were not, there was some information missing. So it would be good now to discuss this, with the Toby, and then say if these information are not available, that's the reason why this assembly caused so many troubles. To be honest, when I see the case study, to me, I mentioned that the exploded view is not really completely. You cannot really set. I don't know if you might have the exploded view in a better from a better viewer directly from the Creo viewer. Have you been able to see the exploded view from Creo directly?
We looked at Creo last night. We were working on that to have a look on it. as well and trying to identify the parts on it, and we couldn't see, like some of these we couldn't really see, and we were identifying other parts that were not actually on the list. We couldn't find out where that's coming from.
Yeah, I think this is one of the, a real problems. So maybe they are really missing part. That's why there are no connections. So that's why there are problematic issue. So as you mentioned, the missing information about the component number 4, 8, and 14. So these might lead to some. So, and also you mentioned that the list of the bill of material, and then consequently the list of operation, they are not correct, or they are not in the correct sequence. So all these things are important. That's why might lead to an efficient assembly. So one of the scope of the DFMA is also starting from the bill of material. So if the bill of material is not correct, so there might be, as a consequences, the sequence of operation or the sequence of assembly related to the missing component, that might cause the trouble. So getting to the point that you are able to apply the method and you have all the information is already an achievement. So I think if you come out with these comments and then you see that these information are really missing in the system, this might cause the problem.
Yeah.
So that's why it would be interesting if all the groups come out with some missing information and then see with your manager if this information exists somewhere or they don't exist. If they don't exist, this might be the problem. So this means that you have to redesign the sequence of operation. But the most important thing is to identify the bill of material. So the missing part need to be identified. So what are these missing parts? I'm pretty sure there should be. So if there are missing parts in the system, so this might cause the problem.
Because am I right in saying, obviously not knowing anything about shipbuilding as such, but am I right in saying that when the fish plates come along, the pipes and the sieves are already in situ, just they're already joined together? Not even sure I know that yet, but I'm assuming that is the case because you'll need
9 times out of 10 it would be.
Because you'll need those. I guess you'll need those in place to know how much green to take off the fish plate to get it to fit nest in.
Yep.
So I suppose you could start almost making up your own sequence, but it's how close to reality do you want it to be?
I think another important information is that what is not manufactured in the company, but what it comes from outsource, it needs to be assessed separately. So you need to understand how the other parts come together, if they come as a single component or as a sub-assembly already. Because if they come as a sub-assembly already, then there might be an error in there, and then you will not be able to identify. Although you might have done correctly all the fish plates and all the things in-house.
So I believe myself and Fraser, we were involved in a CR regarding this a while back. So basically, we were basically getting told to in our outfit shop, we were basically getting told to manufacture the fish plates as a whole structure, if you like, and then they were getting sent down to the ship, and then once they got to the ship and the guys were fitting it, they realised basically the sort of problems that Scott was saying just a moment ago. So from that, our drawings have sort of changed a wee bit in terms of sending the parts loose to the ship in certain circumstances, depending on the size of the fish plates and what pipes they're going on, etc.
Mm-hmm. So that's not really the correct way to do, but
no, but that's the governed way, I'm afraid.
Yeah, no, I know. I'm not gonna blame you or anything, but that's let's say by the book. That's not what need to be done
Aye.
by the book, by the academic one. Let's say the academics, everything. So it's, the reality is different. But you can take advantage of this, making the consideration that doing this is not efficient, it's time consuming, and also not cost efficient.
Yep.
Because
yeah, that's we were sort of saying it's like a lean thing, isn't it? You know, you're sort of, according to lean, you're unnecessarily transporting the components sort of back and forth between
exactly
areas. But it's just we struggle to get our heads around how we would actually do a DFA analysis on it as such, as opposed to
but I agree with you, to be honest. When I've seen the case study, I said, oh, that would be interesting. But one of the conclusion of this might be that really how the bill of material is important. So you can manufacture the fish plate if all the bill of material and the sequence are correct. So imagine that you have never done anything, or you never came across to this. You wouldn't going to manufacture the fish plate at this stage. So imagine this has been your analysis, the beginning. You have never went to the shop or to the manufacturing for the fish plate. So as an engineer, I wouldn't go and say, okay, you can start manufacturing the fish plate and then we'll see what happens, see how it goes. So one of the first things at this stage would be to identify the missing parts, so from the design. So I wouldn't go to the manufacturer unless the design is defined. So at the moment, there are still missing information from the complete bill of material, and the sequence of assembly doesn't seem to be complete or in the correct sequence as a consequence of the bill of material, of course. So I wouldn't send this to the manufacturing department and say, okay, you can start manufacturing now the fish plates. So this is one first consideration. So the bill of material is not complete, and needs to be complete. It means that these parts need to be identified, and then once the bill of material is complete, the sequence of assembly can be redesigned, considering also that some of the parts are manufactured outside, so are outsourced, and so a separate analysis of the part non-manufactured in-house need to be analyzed, how the sub-assembly have been realized, has been made. So this means that we can assume that the sub-assembly are correct, or if there is any constraint, which mean any constraints for the fish plate. In order to make the fish plate, there are some constraints that need to be respected, need to be considered. Some information to the outsourcer need to be provided. Say, for example, you said the pipe number 4. So you are not sure how the pipes are assembled. As far as understood, those are outsourced. So this means that from the supplier needs to have some discussion and see how those parts are assembled together. Because I think that would be one of the consequences as well, because that's what that's where all those pipes come on top of the fish plate. Is that correct?
Our pipes aren't outsourced; we make them ourselves.
Yeah, I think that's a bit of a grey area there, because we have a pipe shop in Scotland, so I suppose they're manufactured to a drawing. We build them in-house, but they're built and then sent to store, and then they would be called out to ship. So they're not manufactured on the ship to suit the kind of as-built compartment, but they are manufactured in-house, but yeah, from a separate department.
Mm-hmm. So it's important to have even if you remember, again, the concurrent engineer, all the information need to be aligned. So you can have, so it might happen that you have problem because there are parts manufactured, outsourced, or even from the same company from different department. But then you need to make sure that the bill of material is the same. So you might have, the bill, maybe these parts are going missing because from a lack of communication, the flow of information along with the flow of material moving need to be tracked. So that's why there are now systems which you might have centralized all the database. But if not, means that you need to, so ideally, all the bill of materials is in a common database. So you might access to the same database or other company or other department are access. So imagine that you are responsible for the fish plate only, no? Other departments are responsible for the other, but you all of you are as a common database with a bill of material and sequence of assembly. If the separate department create their own bill of materials, then it's not gonna have. So then I've seen another came across to, and also we realized as a research for other company, centralized database. So then anyone has the same bill of material, and then if something changed, automatically it's gonna be visible to the other one. So now the consequences and the conclusion for this is that you need to gather this information in a way that you be able to understand the reason why those components are missing. So all these consideration that you came across, you came out with this consideration, they are normal as a consequence of the DFMA method and guidelines. So it makes sense to me that there was something missing, because you can arrive at the fish plate was such a problem. So it was immediate, in my opinion, that was something, a missing information or a miscommunication between the design and the manufacturer. And then, as one of you mentioned, I don't remember who mentioned about it is not lean, because it's not the correct way to design. Which, if a part goes back and forward, that's a loss of efficiency, which means which is translated in a loss of time, a waste of time and cost. Because even all the remanufacturing that you are doing, so that's a cost, which affect even worse of the design. So a redesign, it can still has an effect, but not as much as if you have to remanufacture a component. Okay, so any other comments from the other group? Maybe any other groups has considered the other assembly.
We do actually, there are a few more slides to go through.
Yes,
that.
Go on.
That wasn't the end. So we also looked at the drawings of the two fish plate types and made a sort of a comparison and analysis of those. Made a few comments on those. So I think it was already mentioned last week. A lot of people have queried, could you standardise the fish plate design? But I know a lot of people are saying it. I guess it depends on the shop characteristics and what function the fish plate has to perform. But I also think there's an argument that you could perhaps try and standardise the drawings themselves and the way the information is presented, which would be sort of more efficient. So I just listed a few notes I made. So for fish plate 1, I think this was pointed out in the brief, that note 1 states that you match drill the flange plate, but then associated note 4 said to drill it at shop. So that was on, so in the view it said drill on ship, but then when you followed the notes through, it said drill on shop. There's a few other things. So on fish plate drawing 1, you actually have the green material actually drawn on. Whereas for the fish plate 2 design, I think the drawing is actual final size. So you've got like one standard has got the green drawn and the other doesn't. But it just has a note saying additional 25mm material required. But I don't know if that is clear enough as to say where the extra material is required. So one drawn looks as if it's telling you the manufacturing state, if you like. The other one explaining the final condition.
Are they two different sizes? Is that the two drawings? Are they the same?
I think so they're both for different fish plates, right? One's the sort of L-shaped fish plate, and the other one's the, excuse my rubbish terminology, I don't know fish plates well. Another one's this sort of V-shaped fish plate.
Yeah.
So on the V-shaped one, whoever's drawn it is actually drawn the green material on the bottom of the stiffeners and the flange plate, but it's drawn final size on the other one. Just a comment to say, I think it more generally, the final comment, and even the way the notes are structured and what's on there, the one that's got the green drawn on it kind of almost tells you how to manufacture it. So it says, drill these holes in place or drill these at shop. Whereas the fish plate 2 drawing just kind of shows you what that fish plate's going to look like when it's finished, and it doesn't tell you how to do it. I think it's always an interesting thing is when you do drawings, should drawings dictate the manufacturing process, or should they just show final state and then it's up to the manufacturing guys to determine how we actually get from A to B? It's I don't know if I'm right or wrong, but it's just a comment that both of them seem slightly different in that regard. Yes, so on fish plate 2, the green material wasn't specified. In fish plate 2, one of the notes, it talks about drilling equipment fixing holes. All equipment fixing holes, but me being someone who's come in from outside, what are the equipment fixing holes?
Yeah.
Is it just the ones that will go through the pipe flange? Is it also the ones that go through the seat, or is it both? Is it both, or is it one or the other? That's
Scott.
Yeah.
There is a separate drawing to show you the pitch for the diameter of the pipe you're fitting. So my understanding would be it would be the fixing holes around the pipe.
Yeah, so it would be the pitch, the radius holes, radius. But you know what I mean? No, it's not just if you look at that drawing in isolation. If you're a subcontractor who's being asked to go and produce a bucket of fish, fish plates, it's not necessarily clear. You need to have experience to understand that, I guess.
Yeah.
There's technically a drawing, and we're missing a drawing then. It's for that.
Jason, there's a drawing which shows standard fixings for the pitch of the holes on different sets of pipes. I'm not sure whether perhaps the only thing that's missing on the drawing is there's not a note referencing that.
Yeah. It's just a clarity thing, really.
Yeah.
You know what I mean? And I think it's the same even with the subcomponent names. So if in the notes, I think some of the notes will talk about base plates or flange plates, but in your detail list, your sort of detail bomb, you use numbers, but in the notes you use names, and to me that could potentially confusion. None of the subviews have, so when I was reading, I had to say, all right, I think that's the base plate, and I think that's the flange plate, and to me, it's just some of it's just almost admin stuff that it could just be a little bit clearer in terms of and consistent in terms of the drawings when you compare them sort of one to the other.
See, just on your point, Scott. I know what you're saying. See, recently, or I'm assuming it's since this kind of pack's been put together, but one of your colleagues, Toby and Joe, that was on the call last week, they were away for a few weeks looking at drawing sort of standards. So it was basically, I think it ties in with what we're talking about here. Basically, if I'm doing a drawing and maybe like just the names I can see the new, like Archie or whoever else is maybe doing a drawing, say it was us, they weren't really working off a standard at the time, so I would maybe give more information than Archie would, or probably Archie would give more information than me. It's just so they are kind of going away and working on that at the moment, and some good stuff came out of that. Kind of what that Toby and Joe were part of, as I say, a few weeks back. But it's as I say, that's part of that and part of the that's going on at the moment.
Right, so a lot of these things will probably be being addressed just to get that consistency. So yeah, so if you get four designers, you'll get the same output. Yeah,
that's kind of what they're hoping for.
Yeah, so it was just So it was little comments like that. So and even the definition of the radius of holes, one defined them as a pitch circle and the other one defined them as sort of as linear dimensions. So for the flange plate, these have all each hole with its own dimensions from edges. Whereas I think in the other one it's defined as a radius on a radius equally spaced. So again, yeah, it's just as you were talking about there, Paul. It's just getting that consistency. So whenever somebody picks up a fish plate drawing, they sort of know what they're going to be looking at. Noticed there was just again another comment. Sorry, don't. There's no tolerances anywhere. I don't know whether that's important or not.
And I think this is another big problem. The tolerances. I don't want to imagine that really tolerances are not defined. Geometrical tolerances. They are dimensional, but the geometrical, that's what they give you the perfect match in the assembly.
Yeah, and I guess we're in the air side, we're probably maybe a bit more used to using detailed tolerance sort of standards and stuff like that than the ship's guys are perhaps. So in the notes, even the notes, necessarily, it wasn't immediately clear which note, maybe which individual element of the fish plate. And as I said, some of the subcomponent names could maybe just be clearer or tagged to the relevant item in the bill of materials. And then that final point, so the fish plate 1 type, definitely the notes would talk about match drill these at ship. So that's really, to me, that's don't know what you guys feel about it. I don't think there's a right or wrong answer, but that's kind of dictating how you do the job then, isn't it? Because for you to then change that, if you then said, I want to drill these holes on shop to make it more efficient, you'd then potentially be going against what the drawing actually tells you to do. So you might need to change the drawing as well as your manufacturing sequence. As the fish plate 2, it kind of just shows the final state. So therefore, there's probably maybe a bit more flexibility in terms of where you actually drill and trim and do whatever, and weld and do whatever you need to do. I guess it's about, as well as getting a standard, it's about agreeing what that standard needs to look like, how much content should be in there in terms of showing green material and telling you at which stage to drill holes and that kind of thing.
Yep. So see the 2 drawings that we're talking about. I've just noticed there the names are different on them. So basically that is what Toby and the team were kind of. I'm not surprised that this is the example actually now that I'm sitting thinking about it, because Toby's obviously, am I right, Adelaide? Toby's provided this.
Yeah.
These are the examples for the brief. Yeah.
So this is exactly what he was working on. So that's.
So it's quite deliberate. It's quite deliberate.
I think so. Aye. Aye, it comes down to not having a drawing. You see, you can take all the who fits what, where, and when. But yeah, in terms of what you're talking about, in terms of the drawing, it comes down to not having a standard of how we write, how we create our drawings.
Yeah.
And once we kind of sort that out, then we can hopefully move on to kind of fitting things in the right order, in the right place.
Most optimum way. Yeah. Okay, so that was just an analysis of the two drawings and comparing them. I'll hand you over to Archie now. He's going to talk through some ideas we had on how we could make the assembly more efficient.
Well, guys, yeah, so just to kind of go with what ME usually does is try and find a solution. So we decided, obviously, going through all the information we went, is there an easier way of doing what we're trying to do? So there's a couple of ideas we've noted down here. So it's to complete the fish plate in the shop, remove, minimise on-ship operations. So basically, that's where we kind of termed it, obviously, for the norms of the build, probably doing things in the shop is a lot more efficient than on the ship. So we tried to look at that view to see if we could improve the process. So the first one was add green material to the top of the flange plate and trim on final fit only. That was obviously one of the solutions that was given to us at the start of the assessment. That was something that Toby and the team are possibly looking at. But we had a discussion on that, and that probably wasn't the best solution, really. It would create a whole more issues, really, more trimming at ship, etc. So we could more or less discount that one, to be honest. But it's obviously worth a consideration anyway. Second one is complete the fish plate assembly and pack underneath to suit on the final fit. So basically make the full assembly and then maybe shim it. But the problem with that is you probably wouldn't drill the holes at that stage, but at least you've got a finished tight fish plate assembly welded. But again, it probably wouldn't be painted at that stage because obviously you've probably still to match drill at ship, because to be honest, you're never, for the flange orientation with the holes, it's very difficult. We did discuss whether you could maybe make the holes a bit bigger so you've got a wee bit more fit space. But again, with Type 26, we took a consideration as there's lots of issues with vibration, etc. So you don't want the holes too loose that might create vibration and noise, etc. So again, something to consider. The other thing we thought was measure required green removal by surveying the flange height requirement, complete manufacture of fish plate in the shop. So rather than taking the parts with you onto the ship, is to get a measurement done once the pipes and the strainers fitted, and actually take the measured sizes back to the shop, and actually manufacture the fish plate to the kind of surveyed dimensions, which would give you the opportunity to complete the whole thing. I take the green off in the shop, weld it all up, get it painted, get the holes drilled, all in the shop, and then just offer it up. So again, it's probably a good option, but obviously you need to make sure it's planned into the schedule, that you've got time for the manufacturing shops to actually make them piecemeal like that. The final solution we considered was a modular type manufacture, which is basically fit the pipes, the strainer to the kind of framework as per a modular idea, so that basically everything gets done in the shop, and the fish plates could get kind of measured and manufactured in the shop, and fitted to the module before going on the ship. But again, it's something worth considering. So that was the kind of 4 options we went down. And go to the next slide, Scott. And that's kind of a wee breakdown of the brainstorm we had regarding some other aspects of the actual. So the one before was really the assembly type thing we looked at, is how to assemble it together, looking at the whole picture. These ideas was specifically on the fish plate itself. So fish plate 1 was maybe reduce the stiffeners, so make a kind of as it's shown there. So the triangle basically, which is the 2 separate webs at the moment, make them one, and then just kind of fillet weld them onto the edge of the flange plate, and obviously weld it onto the base plate. So you're basically getting rid of 2 of the kind of stiffeners. Fish plate 2, a couple of options there would be, again, reduce the stiffeners to 2, and basically analyse what's the size you would have to be. Would they have to be thicker? Would the plate need to be thicker to compensate for reducing the stiffening? And also another option would be, could you slot them so that you're making one plate, and you're just putting slots in the flange plate to fit them in. And also, could green be removed from the stiffer plates, so green only in the flange plate? So a couple of options at the actual fish plate itself that we looked at. And the next slide, and this is basically what some of the design steps, possibly, especially designs, the idea number 3 for the previous slide was to do all the base everything at the shop, cut parts, weld assembly together, drill baseball plates, paint fish plate, and then obviously the ship processes. So the objective is to finally finish the fish plate in the shop without being taken to the ship and then removed to finish. So just try to cut down the amount of times the fish plate's actually going back and forward to the ship. So again, that was just something we kind of did a brainstorm yesterday to come up with some solutions. But Scott mentioned at the start, it's slightly different from the butterfly valve option when we were kind of trying to reduce the parts to a certain extent. This is more a kind of lean type exercise, really. We're not necessarily getting rid of a lot of parts, unless you go on and try and get rid of some of the stiffeners or some of the brackets. You could probably do the DFMA type process, but we took a lot of the view that it could be a manufacturing process rather than reducing parts. So that's basically where we got to with these ideas. So I think the next slide was that Robert, yourself, who did you go through these ones?
Yeah, it is. Yeah, thanks, Archie. Morning, everybody. So yeah, so bearing in mind what the guys have just been through, and with regard to trying to look at doing as much of the work in the shops rather than at the ships, obviously, to save complexity and time, etc. We've got like a few queries. So the first one being is what gap is allowed between the pipe and the fish plate after cutting, so that we can factor in like shimming philosophies or green philosophies. So I don't know if anybody in the group can answer that. Is that, does the pipe actually come into contact with that radius, or is there a design gap in there? Because obviously, if it does, you could possibly get like I know it's bolted to the flange, but you could almost get like metal on metal contact, on the pipe, and whether or not that's seen as a no, or whether or not there is a gap in between that fish plate and the pipe as it's shown in the diagram there. Does anybody have a view on that from the team? Whether or not that pipe does actually sit in that cradle, if you will, or is the clearance around between the pipe diameter and the radius of the fish plate? If not, I mean, that's possibly one of the things that we need answering.
I've fitted quite a few of these fish plates, and I'm not aware of like a standard gap. Yeah.
So, Louis, so what is it? Does the pipe physically just sit in that radius then? That there is like metal to metal contact on the pipe?
You aim to have a gap. But I'm not aware of the standard of it. As long as you can basically get like a cigarette paper in, it's pretty much.
Right. Okay. Yeah, we were just wondering because depending on whether or not there was a design gap on there, or whether it was supposed to be in contact, would shape some of our ideas around, do we go for a shimming type philosophy, or whether we go for the green either putting the green on the bottom of the flange plate or the top of the flange plate, etc. All right, okay, so that's something that we may need to clarify.
Yeah, sorry, Rob, just to back that up. Yeah, it was around it. So if you get 25,
okay.
yeah, so there's like 25 mil of green material. So if we were going to measure, if we were going to try and take a measurement so that we could pre-cut the flange, if that gap had to be a certain min or max value, and that would tell you how many increments you would have to have, because you would want to cut to maybe a standard size, so either take 5 mil off or 10 mil off or 15 mil off. You wouldn't want to have a precise, remove 12.5 millimeters of green. So if you knew what the range you could sort of accommodate between the pipe and the radius, it would, the bigger the range, the less different sizes of flange plate that you might have to produce. It might just be small, medium, and large, or it might be every 5 mil increments or 2 mil increments. But a lot of it would depend on what that gap allowance would sort of be there.
Yeah.
Sorry, Rob.
No, it's a fair point. Yeah, I'd forgotten it. I remember discussing it, but yeah, I've forgotten about that. So yeah, cheers. The other question that we have is do the weight values include the green material? Because for you guys, well, it's the same for us in the aircraft world as well, is that weight is a key factor. So that if we're going to put green on anything, is there an offshoot or are we robbing Peter to pay Paul a little bit with regards to weight? So again, the question was around, when we assess the weights that are in the bill of material, is that including the green material or is that excluding green material? And again, I don't know if anybody within the forum can answer that, but it's just something else that we possibly need to clarify.
And especially on the stiffeners, because I don't know whether, could we even get away with having no green on the stiffeners? I think there's one as well, because obviously you definitely need it on the flange plate to get the right height and stuff. But yeah.
Again, other questions were around, are the seats, are the seat holes drilled or blank? And this is what Scott was alluding to before. On the drawing there, it kind of indicates that possibly in that assembly that the holes are already there. But as you say, in certain drawings, the fish plate drawings in particular, it does state, I guess as Scott probably alluded to, it's maybe not clear that, are the holes in the matching base plate of the fish plate already drilled, and then you obviously put the fish plate onto the seat and then drill through them holes as like a pilot hole, or is it a case there's no holes in either, or are the holes in the assembly on the seat there, and that we have to drill the corresponding fish plate to them holes? So again, I don't know if somebody like yourself, Louise, I don't know if you're obviously fitting these things in and around the ship. Do you have any sort of idea, or anybody else for that matter, whether or not the holes are drilled in the base plate of the fish plate, or whether they're drilled in the seat, or whether they're not drilled on any of them, and then you have to drill through both sets of material when you're fitting them at ships? Anybody got an idea or a view? Or did that not make sense?
No, it made sense. It's been a varying I've seen them when you go to the ship, it's drilled on the seat. The seats obviously are checked by dimensional control before it's drilled, so it's like match marked and then checked and then drilled and then checked again. That's kind of our standard for seats. With the base plate of the fish plate, they should be drilled in the shop. There was issues a couple of years ago with when you're drilling them, the holes were off because the drawing was off. But I couldn't comment on that, whether that's improved or not, but I'm assuming so, because it was quite a big problem for like a couple of months.
Okay, so yeah, then that would ask other questions, as I think Scott alluded to. That there's the size of the holes on the drawing, but what sizes, what clearances, do we drill holes a little bit bigger in the fish plate than on the seat, so that we have a little bit of wiggle room, so that we can fit it? just general questions that obviously probably not looking for an answer here today unless anybody has it. It's just questions that we possibly need to add that, you know, ask and find out before it shapes what decisions that we make with regards to which option we go down to, you know, to try and as Archie mentioned before and Scott, that, you know, to try and do as much of this work at shops rather than on ship. Okay. All right. So next slide. So I think this is the final slide. Correct me if I'm wrong, anybody in our team, but I think this is the final slide. We haven't gone as far as to actually put this information into any specific model because we think that there's probably some outstanding questions around the fish plates, the bill of material that we possibly need to get further clarity on before we go and pick a specific method. But amongst ourselves and the team, we did do a little bit of brainstorming and the pros and cons for each of the three methods. So not to go through this verbatim because we probably took up enough time as it is. We kind of looked at all three and looking at as the guys had previously mentioned, because we see this more of a leaner type activity whereby we're not on a butterfly. We're not trying to get rid of we're not got like a top-down type assembly, and that we're looking to try and not remove parts as such, but try and remove operational steps. We thought that the Hitachi method probably wasn't the best method to go down. So as a team, I think we're undecided whether or not we're going to go with Lucas or Boothroyd Dewhurst at the moment. The reason being that we believe that the Lucas or the Boothroyd method give us a little bit more clarity and a little bit more of an assessment around how difficult it may be to fit these certain aspects, which lends itself to the proviso of trying to do more of the stuff in the shop rather than the ship. And hopefully, if we put in them scores about difficulty to fit and assemble, that's why we're currently looking at either the Lucas or the Boothroyd method, although we haven't settled yet, I believe, guys, correct me if I get that wrong, on which one of them we're gonna go with. But yeah, I think for us we've kind of put the Hitachi one to one side and we're looking at either Lucas or Boothroyd or Dewhurst for our team. Okay, I think that's me done, Jensen. Unless anybody's got anything to add to that.
Yeah, I think that's us. It's just really that clarity. You know, the first is really getting clarity on the bill of materials and the build steps, really.
Very good. Thank you, guys. Thanks. So if I would like to make some comments on this. So very, very good analysis. I have to be honest, some of your question and query were coming from me as well. So which makes perfectly sense, because in order to carry out a DFMA, you need to make sure that you have all the information, and then it's not an after fix as currently it seems to be. So some conclusion is it's important, as Scott mentioned, is to clarify on the bill of material. Secondly, clarify on the sequence of operation. And then one important thing is also about what was you mentioned about the tolerances. So the drilling, it was not clear to me as well where the drilling should happen in shop, not on ship. So on ship should only be an assembly. And then I think for the tolerances point of view, it's important to, for example, considering a datum. So a datum which is might be a plane, might be any plane, a reference, which makes sure that anyone is going to manufacture the fish plates is not going to have any problem in putting the back and forward. So it would be good to clarify something about the geometrical tolerances of the holes of the fish plate and the seat. I don't know if this information they don't exist, then might be one of the reason. I think the green material, as far as understood, is a consequences of the misfit. So that's a way the green material has been introduced to play with. It gives some way to cut the green material and make sure that the fit is correct. So if this is not the correct way to do it, so the green material, or why has been introduced the green material? That was another thing. Why the green material? Is the green material for any other reason apart from the fitting?
No.
Green material is just there so that when we go to fit it at a ship, it depends. It depends what state the pipe's in. You know how much we need to cut off.
So that's. So I think the green material has been. So before introducing the green materials was suggested. So I think the drilling and then the seat need to make sure they are in the right position. How to determine the right tolerances, geometrical tolerances for the drilling. So tolerances is another topic which is quite complex. So it's not straightforward to identify the tolerances for such a complex assembly, but they are necessary. So you expect that a GD&T analysis would be carried out for this type of assembly. And then for another comments is about what type of method to apply. So I agree that the Hitachi is not suitable because it's not here a matter of reducing the number of parts. And let me specify also that DFMA is not only reducing the number of part count, so it's one of the principles, but it's not always the case. Lucas and the Beetroot seems to be the most suitable, and to be honest, you might apply both because they are complementary. So Lucas might help for the fitting and handling, and then the Beetroot to look at the efficiency. So I'm pretty sure that you might have, because I think assembly time is going to affect, based on the consideration, the assembly time. I don't know if you have already this number. It's not efficient if the fish plate goes back and forward. So, and I think if the fitting is improved, consequently the assembly time as well. So it would be, I think it would be good to apply the Lucas first, and then the Beetroot as well, because I think the assembly time is important in this assembly.
Adelaide, just a question. So if a part's going back and forth, so if it goes to be, say, measured and then trimmed and then it gets sent back and then sub-assembled and then sent back to the ship again, would you include the assembly time? Would that whole time be the assembly time?
Yeah.
So it could literally be hours or days if the parts, going back and forth.
Yeah.
Okay.
Because you consider the assembly time from the beginning to the final, so you have to consider you're gonna see this one in module 2. So the add value and no add value time. So it will be part of the lean exercise of a value stream mapping of the process. So the assembly time is gonna be, let's say, the assembly time by definition is the cycle time, so it means the add value time. But when you have to consider in general the efficiency, you need to consider the lead time. That would affect the cost. So the assembly time will be, as you mentioned, the add value time. So when the part is assembled on ship, or is assembled on ship. But if the parts needs to go back, then it's gonna be a time for transport time. So it's another adding time which affects the lead time is defined. So you need to consider that, not in the Beetroot method, but because it's the assembly time, you're gonna consider the assembly time, but on the efficiency affect dramatically if the part goes back and forth. It's gonna be a time, not add value time, because is time to bring the part back and forward, which affect the total time to complete the assembly. So this is another tool for the lean manufacturing, Six Sigma, to look at the efficiency of the process. So we're now looking at the product first and how the product analysis affects the process analysis. But then when the product analysis has been completed, you need to map the process. So, for example, in this case, it's not only assembly, there are also manufacture time. So you map every single process. So you move from a single assembly to the whole system. But that's another story. But that would be the part of the module 2. But if the part goes back and forward, it's dramatically a waste of time and cost. So ideally, yes.
See, we're talking about parts going back and forward. Can I just bring Fraser into this if he's available? Are you there, Fraser? No. Aye.
Yeah, I'm here.
Right. See the CR that we done?
Aye.
Correct me if I'm wrong. Did we not say drill the base plates in the shop, dress all the parts, send it to the ship, and then it get fabricated at the ship to suit?
No, it was the other way about. It was the flange we drilled because the flange
Sorry,
will
the
always
flange
stay
plates,
the same.
Yep.
So the pitch and diameter of the flange holes will always stay the same, but it's the base plate holes that you sometimes need to change for fitting out.
Aye, because when we looked at it before, Kenny Percival then showed us the shock mount that it goes on as well, wasn't it? And that was a whole different ball game altogether.
Yeah.
So see the way that we're doing it at the moment, there's not really a lot of parts going back and forward, if you like. It's basically we've just moved the labour costs from the sort of outfit steel team to the pipe team or the outfit team on the ship. And it's basically getting done on the ship. Aye, it's no ideal, but in terms of the sort of parts moving about and going back and forward, it gets sent as a work pack to the ship and then they fabricate it for there.
Aye, that's basically it in a nutshell. It's just the shop builds it to suit the ship, and then they transfer the oars so that the ship can then weld it up more or less in situ once they've got the holes marked, etc., and the green material. They've decided what they're going to do with the green material based on the pipe and the base plate seat and the stuff that are factors at the ship that the shop can't really predict.
Yeah.
So they don't take the fish plate off the ship into a workshop to do it and then get them painted and then back on, so everything will get done in the ship. Is that right?
Aye. I think in days gone by that's when they were taking stuff off and all that, but now it's just get it on and get it done. So like to the carrier, I think that happened, but
I believe it.
So Mohammed's gone to the mountain.
Aye. Aye, basically, aye. He's took the long road for a shortcut, but he's got there.
So ideally, as in one of the slides when Robert was showing the drones, so I think ideally the drones, they should already tell us how the manufacturer. So from the drawing, you will be able to manufacture all the assembly, sub-assembly, and then on ship will be only a fitting. So anyone should be able to read from the drawing how the assembly would be manufactured. So that's why it's essential having the same terminology, so the same part with the same name, so consistency, and then the geometrical tolerances. And then when you design the tolerances, they have to be referred to common datum. So you can't have one datum on one drawing and then a different datum on another drawing. So then in the final assembly, they will never fit because the chain of tolerances have been designed differently. So the common datum. So which plane, which reference can be considered for the drilling of the seat and the drilling of the whole of the fish plate at the same time to make sure there is a perfect or whatever within the range of what the tolerances design. It might be a reference plane on the ship. It might be sometimes it's even virtual datum, but this means that all the geometrical tolerances are taken from the same reference. So even if they are manufactured in different parts, you are sure that then the fitting will meet the requirement. So I think this might be one of the reasons of the problem. And then, as we mentioned, so the aim is to reduce the number of operations on ship. So from the DFMA perspective, it's better to redesign rather than going back on it.
Can I phone you back? I'm in the middle of a call. Right, thanks, pal. Cheers, bye.
Gavin, you're not muted.
Thanks, Louise.
I didn't know if we were talking on. Any other comment from the other groups? So we summarize the conclusion from the group 4. So what came from this?
Adelaide, theirs is just the exact same as the other groups. That was a joke.
You feel that? I just fell flat in the face.
Jokes don't work so well when everybody's on mute.
That was so bad.
He's gone scarlet red over there, man.
I thought that was quite a good joke.
Don't listen to them, Gaffer. Don't listen to them.
Oh man. Come on, that was a great joke, Rusty. Oh.
So what have you guys got then? Good.
We've pretty much got something very similar. We decided to go with the Lucas method. We split it up to add in penalty points. That's something that we're going to be doing over the next couple of days, and then we're going to come together with design idea changes for the right hand side of the assembly, and then we're going to see what kind of changes we can make with minimising parts and minimising the transfer time between the ship and the shop, whether that be that the ship does more of the work, or the shop is fine as long as we can minimise the transport time between it, because obviously we have a big problem as well in our work that things that travel don't always make it to the destination. we like to lose things. So yeah, that's pretty much the stage we're at just now. We're making steady progress on it.
Yeah. Thanks, Louise.
Billy, can you present the screen, please, pal, and I'll talk through ours where we currently are.
Right, upload it up now.
Thank you.
Right, see the screen now?
Yeah.
Yeah.
Thanks, mate.
Okay.
So
I just need to run through it list because I've got two screens up. It thinks I'm presenting on this screen that goes a bit wacko.
Right, okay. So basically, task was to provide a design review for the fish plate sample 1 existing manufacture procedure and apply any of the DFME methods previously discussed. So move on to slide 2. What we've done is we've cut up the bill of material to identify by parts. One part there to change. Then we had the original design assembly instructions based on how we were going to approach the task and carry out the work associated with fitting the fish plates. So if you go to slide 5, that's currently where we are at the moment. So we've started contributing numbers. But for us, fundamentally, things at the very start that we had looked at was what we currently had and whether there was an opportunity for improvement. So you had diameter of pipe, unlikely that you could do anything with that. Method of fixing, be it solid on the seat or whether it's arm mounted. So that should potentially have been explored at the design stage. Noise production, both from the system and hard mounting. So it's unlikely that that would be changed. Weight of the valve and relative position on the structure. And I think that's potentially what's driving the two different fish plate designs. So we went back and asked some questions on that. So basically we were told that the design of the fish plates is done in accordance with the shock risk if the ship was to sustain damage. So you were unlikely to have an opportunity to improve that, given that basically the system runs where it needs to run. The loading of the system, as in what pressure it was taking, so again, you're unlikely to change that. And probably the other thing that hasn't previously been mentioned is on the valves, the actuator position relative to the valve. And what we were explained was that the design of the seat is based on worst case scenario where the actuator itself acts as a pendulum and the design and makeup of the seat and fish plate are all done and calculated for worst case scenario. So potentially by moving the valves, you might be able to improve the design of that. So our proposed solutions are that fish plate are able to function in a more effective situation, and in doing that, basically seeing whether we can pre-design all the fish plates and take up any gaps that we have with shims. So, any
I
questions?
think it's fair to say, Gavin, that the first thing that were on, we came across a lot of the same issues and kind of constraints that they did. But yeah, looking, obviously the drawing shows kind of hand actuated valves with threaded actuation, but the information we got from design was that it could either be an electrical actuator or air operated actuator, which is quite a good behaviour. It would obviously add to the stress, and that's why the fish plates are designed as such.
Oh, MD, got any questions?
Just one for me, guys, is that you've managed, your list looks a little bit more packed out than ours. Did you guys manage to rationalise the bill of material there? Because it looks like you've got like more bits than what we had in our bill of material, plus you've got the weights, etc., where we saw that weights kind of missing from the original bill of materials. Have you managed to interrogate either Creo or some other systems to be able to rationalise that bill of material there?
We cheated and used forehand.
If you need information, Robert, I'm happy to send it on.
I appreciate the honest.
Yeah, it just looks like it's a bit more padded down than what ours is, or what we deem original bill of material. So yeah, I was wondering if yeah.
But Mr. Banks and to tutor you, we used the initiative. We didn't cheat.
Well, resource.
Yeah. Used more resources than anyone else had.
That's the correct answer.
Definitely.
In that case.
So you cheat.
No, but it's important if you got this information.
Yeah, I'm letting you know, boys. But I have a copy of it. I can send it out to you. It's no problem.
Any questions? Who's coming to visit Four of us in jail?
Or baseless allegations.
No, I think it's important if you work out to collect all the information from the bill of material, then it would be nice to share with the other groups if they are taken from other sources. No, make it up.
Yeah, no problem. I'll get a copy. I'll send a copy of it on.
Yeah, you can put. Yeah, you can share on the between. Or you can use the open.
What would you send it? Then you can load it onto the website.
Yes, please. Yeah, maybe yeah. So then anyone has the same source of information. So that's communication. Common database in this case is the Moodle page. And then the 4 groups represent the 4 departments who are working on the same thing. So that's the let's align the approach. I have
no
just
problem.
like a question. Yeah, thank you. Just a comment. So you apply the Lucas method. So what are the conclusions from the current state? What is the handling index and the fitting index? So what are the considerations from
well,
this
I mean, look, kind of people and material. Again, kind of back to the same conclusion that if you can get an assembled part of that ship ready to use, then you save that motion and movement of people and material, and then hopefully using shim, just shim first time.
Mm-hmm.
But that was kind of analysis looking at it from others. After having, I've never found it before. There just didn't seem to be quite a bit of movement of the people, and the key we thought to the design for assembly question would be to reduce that and get it assembled in shop in a controlled environment, produced single part number, and then just take up any variation you have on ship with the shimming.
Okay. So what do you mean with the shimming? With a green material?
Rather than having green material on it, we just make it to the smallest nominal size, and then it's a fully assembled in the shop. And when you have to take up any spacing, basically lift the fish plate up to align with the holes. We just use a pre-manufactured shim plate for that at 1 mil, half a mil to take up. So then there's no loss in there's no real loss of material from the or wastage from the green material. You're building one part number to size, and then using the shim plate to lift up and take out any tolerance in there or build errors. Then you be able to assemble it at ship first time by lining up the holes rather than having to walk up and down the ship to machine it, take it back up, offer it up, take it back down, machine again, and do it that way.
And another thing is, if you go to the previous slides, number 4, where you have the sub-assembly list. Yeah. They are in the sequence. So, for example, now what is the sequence of the sub-assemblies? So you have 4, 1, 2, 3.
Yeah, the first one was a walk
So
then potentially assembling the parts of the walkway for the plates, both of them, but we'll break that down into one for the final report, and then the final assembly of putting in the valves and the strainers. But we didn't capture the movement. This was the material, not so much the movement of personnel around the ship up and down to machining equipment and stuff like that.
Okay, and based on this sequence, and then compared to the other sequence from the other group, make sure that they match. So it seems the other group look at also the sequence or the subassembly. So this is, so for example, let's assume the first is 1, 2, 3, and 4. They happen in sequence, or they have or they might happen in
because we looked at it, we discussed it, looked at it, making the assessment, having not done the job before, that would happen sequentially, not concurrently.
Okay. But I think, it's important that the bill of material, there is a match, so anyone can start from the same bill of material.
Oh, no problem.
Okay. Any other comments from this? Any other?
Just the Lucas method. The Lucas method spreadsheet was the Excel document. Was that just something you made up, or is there a template we could be using?
Graham did that. Have you taken a template? I certainly did one last week for the Hitachi when I passed on to any of the guys that asked.
Oh, I'm just wondering if there is a template. A Lucas, is it just something we just make up ourselves?
No, there's no with like the Hitachi, there are formula in there. So it's just an Excel. You have to map the table of Lucas map. You have to map so there is no formula involved. You have to map the sequence, the part to the 4 A, B, C, D components. So it's a mapping process.
Right, that's fine.
And then for the be-through method as well, there is no template because you have to work out on the assembly time, which I think in the second stage would be interesting. Any other comment from the other groups?
Only I'm tremendously jealous of, it looks good.
Yeah, I was going to say that. I
think that.
Thank you, Scott. I'm sure everyone else was thinking that, and we're probably just on mute.
Sorry.
I don't know wanting to embarrass you. That's what it is.
Don't you worry about that, Paul. Don't you worry about that. No, if anybody's a copy of stuff, I'll send on to Adelaide. I'll just drop me an email or a line. I can send stuff over.
Yeah, I think that the most important things now that we come up with the bill of materials, so it's essential that there is a common information from the bill of material. And then I think that the comments that came out from the two groups are quite interesting. And then so we already came out with a consideration that the most appropriate method to apply, given the context, is the Lucas method first, because apparently it's a fitting problem, rather than reducing the number of part count. So potentially the number of candidates for elimination is not the problem. And then before going into any method, so the common things are being related to the information. So collecting all the information from the bill of material and then the sequence of operation. So the sub-assembly and then what is the correct sequence of the components, and then how to make any comments from the single fish plate. So anyone else that has from the other two groups any other comments that want to add?
Nah, we just did the Lucas method as well, which was similar to Russell's group. So there's not really much to add on this because I feel like you've discussed everything.
So common aim.
Just the one thing is we've kind of agree on though is what two groups are doing fish plate 1 and what two groups are doing fish plate 2.
Yeah, that was I was just saying that one. So I think the first group,
we're doing the first one. We're doing number 1.
So group 4 is doing fish plate 1. Is that correct?
Yeah.
Yeah, we can do fish plate 1.
So ideally, it would be, as we have 4 groups, ideally 2 groups on the fish plate 1 and 2 groups on fish plate 2.
Yeah, we're doing the right-hand side on fish plate 2.
That's fine. Just to agree who's doing what so we don't end up fish plate 2 or vice versa or something, but that's fine.
We probably should agree that before we start.
Group 1, we can do fish plate 1 as well. That'll make it easy for us to remember.
Aye, well, we started on fish plate 1 as well.
Well, we'll do 2 then, Farouk, if that's easier.
It's not a problem, but yeah, ideally it would be nice to do 2 groups, because otherwise, you know.
No, we looked at both in our group, so we didn't fit into fish plate 1 or 2, so it's no problem for us to swap to 1 or 2.
Okay, because mainly because then the groups can share. You can compare with different. So if 3 are on fish plate 1, then 1 on fish plate 2. The fish plate 2 cannot have any other comparison or any other thing. So that's why I think it would be nice to be at least 2. So then there are some comparison between the groups, not in competition, of course, but make some, comments, something to look at. Because then, there would be nice then to have some common conclusion. So as we have already from today, from the discussion, there's been some common comments, which is important. So to summarize, has been bill of material as the most important things to have a complete bill of material, the complete sequence of operation of the subassembly, and then having a consistency of the drawing. So different design for the fish plates, there is no common terminology, and all the comments, no tolerances. So it's gonna, if the drawings are not consistent, then of course you cannot expect the manufacturer would be perfect or meeting the requirements. And from the efficiency point of view, reduce the number of operational shifts. And then what else? Come out, so from the fish plates, a standardized design, so which means to make sure there is a consistency in the drawings. The tolerances, yeah, I think is very important, but this requires a different study to do, but it's important to flag it up. Anything else that we came out with this? That's what I was listed on my notes. maybe it would be nice also to look at what might be a target. Do you know for this assembly a target in terms of efficiency, time efficiency? So do we have can we identify a target? Or we simply we analyze the current state and how might be a new improvement state. Maybe it's something that we can just focus on this at the moment. But when you come out with a new state, so the new, after the DFMA methods, you come out with new design or new improvement state, which is quantified by an index with the Lucas, and a better improvement efficiency in terms of assembly time, then you might consider if it's sufficient or is still far away from the target. So what is the target? It would be nice, interesting also to look at what is the target for this assembly. It is the, I think as far as I understood, is the assembly time, which affect the cost of the manufacturing. Anything else that might be a target? We can set it as a target, so we want to improve, so reducing the number of operational ship, and then the efficiency. So let's say the B-fruit method might be the final conclusion. The efficiency of the assembly from the time perspective. What do you think?
Yeah, it's something we could do. Like efficiency, and also, let's say that's one of the things you looked at is like your Timwood, like your main principles like transportation and things like that, and also the quality of it, get it right first time and things like that. You have to take it away and change things. So that's something we were looking at as well. Improvements.
Mm-hmm.
That's something we can add on is for the future state and how that impacts on it and things like that. What the improvements could be.
Could one consideration be to maybe try and reduce weight? I mean, there's probably not a massive opportunity for it, but I didn't know whether that would be a consideration that we could. You might not be able to set a target, but you might be able to say, "Oh, the new method can't increase weight or whatever." I don't know. Just wondering if that would be a consideration for you guys and ships as well. Nope, then.
Yeah, like I said, for 26, weight's a big thing. So yeah, if it does increase weight, fantastic. You know, that's all towards it. Because we might say it's only a few bits, but then the number of these fish plates might be hundreds of them, thousands of them, or something like that. But times that by the potential weight saving, and yeah, it'd be beneficial. It's also like cost as well, like any scrap or anything like that, and reducing that, or if there's any, I don't know, some of them have to be redone or something because they can't do anything. So potentially, if there's anything that way, I mean, it's looking at the MI process and how they do it and how they install it, then maybe speaking to some of the guys installing, getting feedback from them.
Yeah, I think absolutely. When you talk about assembly time, then of course the time has an effect in cost. So work out on the time, then you can then realize the time saving in cost how it's translated. Anything else? So what's next now? So today is the last session, but I want to make sure that there is a common way to proceed for the new state. So we brainstorming on the current state, and we found what might be a potential way to optimize the assembly. So I will still keep the platform open. So maybe from any time that you have a new updates, you can share submitted. So I will have a look and give my comments on there. I will also summarize these points. Although you have this session is recorded, so this we summarize the key point of the analysis, and then the final submission is the 11th or the 12th of January. I don't remember what was set in the welcome package, so it should be the 12th of January, and then so. Is a presentation. You can use the PowerPoint or you can use a Word document. It's up to you. And then I don't know. I need to discuss with Dobby and you and how if they want this as a showcase or just a submission and the comments exercise.
Potentially daft question here, Adelaide, but see when we're submitting it as a group, does one person from the group submit, or do we all submit the same thing?
No. One submission is a group work, so yeah, one per group.
Okay, thank you.
But and then of course I will see the name from the submission, but yeah, of course, an introductions you put look at which group you are, so.
So is it a full submission of what we've done today or this week, the current state with all the workings we've done with what we propose to do for the improvements? Is it taken as a whole pack basically on the 12th of January?
Yes.
Yeah.
So you're already halfway. So let's say group 4 has already done halfway. Has to do only the future state.
Yeah.
So what the showcase of today of the group 4 is what is I expected from the DFMA analysis. And then of course a lesson learned, so a conclusion drawing from an analysis and a critical analysis from the results of the future state, so the improvement.
So Adelaide, so just to be clear, so so we were in group 4, so we hadn't actually done although we've made an assessment of
the current state.
The current state, we haven't, like the other team have got an actual completed, Lucas, value. So I take it we'll have to have something similar for Saturday. Is that correct?
Yeah.
Okay.
I'm not strict with this middle submission, but the final submission is the 12th of January. 11th, 12th. We need to check.
Okay, so this submission is just about making sure that we're sort of and stuff. Yeah. Okay.
Yeah, a work in progress. And then of course I'll keep an eye, so then I'll give you feedback. And then of course any question you can always email me. But I think what you need to do, as you mentioned, I will share on the Moodle page the complete information of the bill of material. But any information that you realize that is missing, please share with the other groups. But I think the most important thing is the bill of materials. So that was consequences of all the. So if the bill of material is not complete, then there is no way to go ahead. So you need to complete the information.
I'll just adjust that table I've got, Adelaide, and just put the weights on the bill of material as well, and then I'll send it over to you, and you can put it on the UWS site.
Yeah.
I'll try to get that done today or this evening.
Perfect. Thank you. Anything else, guys? Any comments? Any things that you?
Sorry, Adelaide, just to clarify, so are you wanting something submitted this Saturday?
For this Saturday was for the current state.
Okay.
Give you a time frame to manage the work,
Okay.
and then of course, today was a brainstorm for the current, which actually I'm quite happy. So they came out a lot of things. And then, of course, you don't want to work on this during the Christmas. So let's say that if you finish by this week or very latest next week, the current state, then you have the time to do the future state. So I think that mapping the current state is more difficult than the future state, because from the current state you have to work out on the situation. So you realize there are missing information. Then once you have realized what is the state, then the application of the method, we already identify what might be a suitable method. Then is the application of the method, and then the conclusion. So what improvement we need to implement. So how the results of the method lead to what type of action in the future. Anything else? Any other comment? Is everything's clear? Any other clarification? I'm happy here to answer your question.
Yeah, for me, I don't know if everybody necessarily wants to stay on, but would it be possible, Adelaide, to maybe just have a little recap on what you showed for the Lucas and Boothroyd method? Just obviously, it was a couple of weeks ago that we looked at. A few weeks ago now, we looked at it, and we looked for the butterfly valve. It was a bit more. We looked at the Hitachi method. So.
So then you have So it's nice. So then you have the clear picture of different case and different context completely, how the method. So you have already been able to identify which method is suitable for one case to another one. So would you want me to go through the slides again?
If that's okay, yeah.
For me.
Yeah, that's okay. Yeah.
So from the Lucas method and the Boothroyd method.
Yes.
Okay. Bear with me 1 second and I will open up. Did you check if the recordings are working? Because they are working on my laptop. So I'm happy, don't get me wrong, I'm happy here to go through again, but you also have the recording to review.
Yeah, I can read the slides, but yeah, just reading the slides doesn't. Okay, I'll just read the slides. But
no, it's the video.
It seems to be like our BAE Systems.
Okay, right, okay, look at the video.
It's our BAE Systems firewall. It's stopping us from looking at the videos. But if we forward the email that Janet had sent for the videos, we can actually open them up on our phones on YouTube easily.
I'll look off. Like.
Okay. So because it's working on my laptop, so it wasn't a technical issue. So I didn't follow up with you last week to see if it was working. So each session has been recorded. So you have again, you can go through, and then that's not only me. So that's all the discussion you can go through again.
Okay.
But I'm just, don't worry, I'll go through. I'm just finding the. Share my screen. You can see my screen? Yeah.
Yes.
So that's the session, the second session, so the 18th of November. So we'll look at the 3 methods. So I'm going through the Lucas method. So the Lucas method is based on two indices, which is completely you're going to look at the design efficiency. The design efficiency from not the time perspective, how to optimize the assembly time, which is the D-through method, but design efficiency in terms of fitting ratio and feeding ratio. So I'll show you the table. So this is the table for the Lucas method. So that's why you have to work out a mapping the two indices, the handling index and the fitting index, based on the movement and on these components, which are going to go through in a minute. So the method consists of a functional analysis of handling and a fitting analysis. And the resulting penalty factor are what you are going to evaluate into this assembly flow chart. So the design efficiency is defined as the number of essential parts divided by the total number of parts in a product. And the suggested threshold is 60%. The feeding and the handling ratio consists of answering questions about each part in order to determine penalty index. So this is the mapping process with the table. And the minimum feeding index is 1, and the suggested threshold is 1.5. The fitting ratio, the fitting analysis is used to determine penalty value for each operation during assembly. And these values are entering in assembly flowchart. The fitting index is a threshold of 1.5. The fitting ratio is defined as the total of the fitting indices divided by the number of essential parts, and the suggested threshold is 2.5. So, for example, let's work out on the, for example, one of you who has worked out on the Lucas method. Let's take only one sequence, and then, so for example, if one of you share the assembly sequence, and then the Lucas method applied. Let's make one example just for one mapping and see how to decide the handling index and the fitting index for those components A, B, C, and D, and then for the fitting index A, B, C, D, E, and F. So then you can see now how it has been mapped. Who is offering to do this? So if you share one of you, just the for example, group 4, you have done this. So let's have a look at how you have mapped the index, the handling index and the fitting index for one operation.
I say in group 4 we didn't do we've not done any Lucas mapping yet. So we've got the original assembly sequence though that we can share, I guess.
It was Billy's team that did that.
Oh, was the other group? I confused. Was the other group where?
Yeah.
Sorry, I confused. Was the other group, which I don't remember which group. Yeah. So, for example, let's take just one example and see how you have mapped the. Of course, it's an estimation. So.
Do you want me to share the screen again?
Yes, please. So you can see. And the other one, they're going to have the table. So you're going to work out on the mapping for the two index, just to have a practical example. So I stop sharing my
Yeah, I've got another version that Dale did here that's got the table on it as well. You might find more useful to use, Adelaide, if you're instructing. So I'll just share that version instead.
Okay.
I came up with more or less the same figures, but I'll. Can you see it now?
Yeah.
So that's for the handling, and then the fittings split into a different table. So just tell me if you want what one you want up.
So let's have a look at the one of the related to the fish plate. Fish plate for one of that sequence.
So that's the one for the fish plate. We did they'll just split into two different tables, handling and fitting, just for the size of the table. So it would sit better on the screen. So that the handling's on the first tab. If you want to, you'll talk through that.
Yeah. So for example, what you have done. So I cannot read it here. So let's see here. Let's work out what you have done for the A, B, C, and D for the handling index related to the fish plate, which is our best pal now. Fish plate. So let me take. I don't know. Can I take the control and then?
Yep.
Where? Let me see.
I can share the one that was in the presentation if you find that easier.
Request to annotate. Yes, I request to annotate. You send a request to the presenter. Okay. Oh, I lost it.
To be honest, even just seeing that makes it a lot clearer for me. Just seeing, yeah, it's quite straightforward, really, to be honest on it. But again, it's all about knowing what the sequence is, what the parts are, how they're fitted to be able to score them, I guess, isn't it?
Yeah. So I lost the screen. So yeah.
Right. I'll just put the one back up that you'd seen previously. That was open from this morning's presentation.
Yeah. So this is the index, the handling index, and this is the fitting index. So before if the problem was how to map. So for example, I was reading the fish plates. Here, this part from number. I just sent a request just to show with my there we go. So if we focus on here on the fish plate, so if you read the Bill, please, can you read here? Fish plate for?
Yeah, so we split it down into the fish plates for the two different types, or the two fish plates for each strainer.
Yeah.
Fitting them there. Not so much done the welding or broken into a massive amount of detail, like you possibly might want to do.
Mm-hmm. So, what looks like for the handling? So how can we interpret it here? What looks like? We said that the threshold is 1.5. So what we can read from here? You can see that we have something.
Sorry, Billy, see if you share Dale's, it's easier to read because it's got a table next to it there. So it shows you what those values mean on the table.
Yeah, you happy with that, Skinner? Do you want me to go back to the other one?
Yeah.
Adelaide.
Yes, go back.
We've done this one, it's on an Excel, it's got the table next to it as well, but just for the presentation, put both of them onto the same table there. But the Lucas method was pretty simple to go through. It's just it gives you a table for the values and assessing each part against the first category A. There's the size, and it gives you a description as to whether you can manhandle it and lift it in yourself, whether you need a two-man lift, whether you need possibly a hoist to lift it in, or the opposite way, whether it's extremely small that you need specialised tools to handle it, is also kind of penalised because it's a kind of specialist installed in. So the size just came down to going to the weights and see whether we were going to be able to one-man lift, two-man lift, or whether it was going to have to be a crane or a chain block lifted into position.
So from that, obviously, we took that there wasn't any massive issues with the actual handling of the part.
It's more the fitting.
And that's reflecting the scope, but it's more the fitting. But your adaptation bar seems to be covering the fastening part of the score. That should obviously see the score for the fitting analysis 6.7, which is quite high.
Yeah.
And a lot of that's related to the fastening, which is scored as a 6 for each part, and the alignment's only 0.7. Again, if with more information, if there's a particular occurrence number we're fitting on ship, then we'd probably look at having to score the access as well. Depending whereabouts in the ship it was, if we had any issues with access, that might put the score up even higher.
Yeah, and then it's essential.
That's one thing we were thinking about.
I mean, you don't get any context from the picture we had.
Yeah. No, that's the thing. It's like, how did they fit it in? Is there space in there for the guy? Because as you know, one of the major things we have is like a space for the guys to fit on the ship. And again, it's like some people are designing it. There's no actual, the guy can't go and fit it. I've had complaints about that, but again, that's something we were thinking of. And like, is it safe for the guy to go in there to put the fish plate in?
That's another one. See in the fitting analysis, if you look at column D, it's an access one, so it gives you a table. Looking just at that assembly and isolation, I don't think there was any restricted access in it, but I get what Jason's saying is one. I'm looking at that assembly or that module in kind of isolation, but if you're actually installing that at ship, there might be surrounding equipment that would restrict your space and access to just bolt holes or whatever. One of them that I kind of that we couldn't really decide on the correct determination for it is from the fitting analysis, column C is insertion. So I was treating like so the pipes and stuff that if you were bolting both ends of the pipe, like there's a flange on each end, so I was classing that as two kind of insertions. Whereas I'm not 100% sure if that's the correct description of what that column should be. But Billy, can you go back to Dale's one with the table on it?
Aye. You don't need to stop annotating just now. 1 second.
I'm not sure if that column C is supposed to be that the part gets inserted like a kind of male or female contact into another part, or if it is, like I was saying, there's a flange on either side of the pipe, so because that's bolted at two ends, I've treated that as multiple insertions. So if you
that should be Excel there.
Column C. So if you look at the table, it's single insertion, multiple insertions, or simultaneous multiple insertions. So I suppose that's just putting a value on how complex it is to get that part into position. But just from the table, just from the title being insertion, I'm not sure if that has to be like a pin being inserted into a fixing hole, or is it literally the flange meets another flange? They would class that as an insertion.
Yeah, because I'd say the single insertion could be just onto the flange, and then the multiple insertion would be into the flange and then into the seat.
Well, like I says, we kind of class that as just that the pipe has two flanges, so that's multiple insertions.
Yes,
instead of
correct.
A single insertion.
Yes, correct.
Yeah.
So it has to be secured and inserted at multiple locations of that part instead of.
Yeah. It's just our definition, isn't it, really, what we think, and we can justify it when we're doing a score. Well, that's fine.
Yeah.
Yeah, well, I suppose that's the way we move forward, was that as long as we define what we are treating that as, it'll give us a score, and then if we improve it later, you'll be able to see the difference in score, and it'll give
I suppose, it's one of the things, isn't it? In some ways, as long as you compare your new score against your original score, you'll always know whether you're getting better or worse.
Yeah, exactly. Yeah, as long as it's consistent into the two table before and after, the same interpretation. And also, I think for the alignment, difficult to align. It's quite restrictive. That's an estimation, but
again,
I assume there is nothing easy to align.
Yeah, but again, we kind of treated that as the alignment one was. It is pretty obvious to see which way it goes, if you know what I mean. Like the pipe's got a certain shape, and if you're looking at your drawing, then you should be able to see that. But the difficult will come in where the pipe's built in a shop to one tolerance, the ship structure is built to another tolerance.
Yeah,
so whether that matches or not, there might be some rework required.
Yeah. Yeah.
Well, if you go to the handling one as well, see how you've done this one. So the handling part of that we weren't too clear on either, because of just the descriptions there. Is that just to do with the kind of surface or the material, if it's easy to hold, if whatever, if like manual handling, I suppose it is. Yeah, this was one that just it threw up more questions than answers, I suppose, as column B.
Yeah, you need to approximate, so you can. So, for example, the delicate means that is can be related. So it's a combination of A, B, C, and D. So for one part, I assume, for example, you put delicate when it's a very small part, and then untouchable, for example, that means when you need another tool to use for a chemical hazard, for example. So it depends. You need to estimate. That's why I said let's work out on the fish plate what might be an approximation, an estimation of the handling. I don't think it's an handling problem. It's more a fitting problem.
Yeah.
And then if it's assuming that everything is manual, there is no, even for moving the parts, everything's manual. Is that correct? There is no material handling support.
Well, there are some of the rather heavy bits of equipment that will be hoisted in position, so it gives a scope for that, for in column A, the size. So some of them are larger, requires a hoist or two people. I suppose that's the only real. The rest will be manual handled. The fish plates actually score quite low through all these columns, so it doesn't look like the fish plates. I suppose I don't know if you take it just at the value of the high score as a poor design, then the fish plates are one of the better parts in this full assembly. But I suppose that's what Scott was mentioning earlier, is just that the issue seems to be the multiple trips and more of a lean kind of making this an efficient process rather than an efficient design.
Yeah, correct.
Thanks. See on the isolation valves, would they no score as a 0.2 because they're not generally a flow arrow on them?
We just gave it as the orientation's easy to see because the drawing, like you were saying earlier, is that the centre of gravity's off because the handle sticks out in a particular direction, so you can see what direction in terms of rotation.
Yeah, but surely the orientation of it as well makes it, because it should only go the one way.
I don't. It might be a kind of case, or you might orientate for the flow, but in terms of the actual angle of action whether it's at 12 o'clock, 3 o'clock, 6 o'clock position, might be harder to work out. Possibly, Gavin.
Yeah.
Yeah, I think both.
Particularly if you don't have other services already plumbed in.
Both me and Dale have just treated it as when the valve's closed, it's at 90 degrees to the pipe, and when it's open, it's in line with the pipe. So whether it was facing forward or aft, it would still open at 90 degrees. So.
Sorry, what's the story with the isolation valve?
It's just that the isolation valve is shown on the image we've got. It's hand actuated, so it's quite a small valve. But when Gavin spoke to the guys concerning the stress, that it can come with a different actuating method on it, which might be either air driven or electrical, which makes it a bigger, bulkier item, which can then act as a pendulum. And that's why the reason was behind the kind of beefing up of the design on the second fish plate.
Interesting. And then this part here, the pipe under the isolation valve, what is this pipe here? Is the big pipe?
Yeah, I would need to look at the diagram. I think so. Yeah.
So, for example, even if there is a large part involved, a large and or heavy, and then that requires even not only one people or two people, but even some material handling support, then you have to focus on the manual side. So we consider requires host or two people. So putting always the worst case scenario. So I assume how the pipe are get to sit on the strainer.
Yeah, that's a fair point. Yeah.
Okay. Anything else? So that's the Lucas method. It's a mapping process, and then of course, as long as there is consistency in the current state and the future state, how you have interpreted the handling and the fitting. That's interesting. Noted how the fish plate looks not the main problem, because in itself, the fitting analysis and handling analysis doesn't come out with a problem, but because maybe that's more a design from the beginning problem. Maybe it's more the tolerances is also another aspect to consider. But if you,
I think it might depend on how far you break it down.
Yeah.
What degree? Obviously, the fish plate score might possibly change then.
Yeah, and then you're gonna see the assembly time. So on the whole aspect, because what you are going to identify with the Lucas method is the single part, and then you're gonna see the two indices as a sum of the single analysis, but not how the things are interacting. So that's why it's important, because at least you're gonna have an idea of the fitting and analysis. So it's a design efficiency from the fitting, from the penalty perspective in the fitting and analysis. But then you're gonna have more information if on top of this you put the time. So I won't be surprised that the B-Truth analysis, B-Truth method will give more food for thought.
Yeah.
But you can see that for the Lucas method, what is essential that you know all the sequence the correct, again, the bill of material and the sequence of, you need to have sure how the part is gonna, what is the motion of the part against another one. So the sequence of operation are the baseline for the DFMA. Okay. So thanks, Billy, for sharing your work here.
No problem. It was David Graham that did that work, so thank you.
Thanks, guys. That was useful just to visualise it all. Thanks for that.
Yeah, thanks. Cheers.
So I'll go back on the Lucas method. So then the other one that we look at is the Beathurst method. So this is, again, we mentioned on the assembly time. So, and then also the first thing is to establish if the operation is manual, is automatic, or robotic. So in our case, we are assuming this is manual. So we need to have the assembly time. So this is the total handling and insertion time for all the parts. So you need to estimate the time for each of the sequences. For with the assembly of the operation, you might have used the Lucas method, but you can also estimate a time for each operation. That's an estimation. You might have roughly, so you can use this information taken from what is currently, I think that there might be recorded for sure in some, but if not, you need to have an estimation. If you are familiar with the operation, then an estimation of the assembly time. And then you work out an assembly cost. So of course you can consider the wage rate and the overheads. So there are a few, I think you have your own formula to use for in the company to work out on the cost for the labor and then associated to at the time. Then you identify the theoretical minimum number of parts. So in your case, you might consider the same number of parts because you haven't eliminated, potentially you haven't eliminated any part, potentially. And then the design efficiency, this is defined as the theoretical ideal minimum time for the assembly divided by the actual estimated time of assembly. So let's work out. Do you remember this was the purpose of the initial design of the motor drive, and then we apply just the principle, not any method, which part potentially can be eliminated. And then from 19 parts, we reduce to 4 parts. So this is something like the list of parts, and then the theoretical part count. So from 19 to 4. And then the assembly time and the workout on the assembly cost. So the manual assembly efficiency would be given by the theoretical part minimum, and then multiplied by the theoretical lowest assembly time. This is an ideal minimum. And then the TMA is the estimated assembly time to complete assembly of the actual product. So,
Adelaide,
yes.
Adelaide, just get a question.
Yes.
So, but we're not really reducing the part count in the design as such. I think we've said that there's probably a limited scope for that. So when we're doing this analysis, so let's take the flange plate. So currently it goes to the ship.
Yeah.
It gets measured to have its green removed, and then it's taken back to the shop, and then it's attached to the other bits and taken back to the ship again. So for this artifice, would you actually treat that as like 3 parts because you're working the same physical item 3 times?
Yeah.
Is it valid to do that?
Yeah, that's an approximation of the yes.
Because then you clearly see the difference then between working it just once than working it 3 times.
Yeah, of course. Yeah, correct.
Okay.
Because again, it's a theoretical, so that's correct. So that's a good point to go back here to the method. So then you can see that's a theoretical part minimum. See, it's not only applicable when you have reduced the part. Also because it may be more different. So this has been an example where you have reduced the part from 19 to 4, but you can apply the method in a different design where you have reduced the part from 19 to, I don't know, 15, 12. Yeah, that's a good point. So I'm happy that we went back on this. So where the minimum, the number, the theoretical part minimum is 4, and then you remember you're going to look at the theoretical lowest assembly time, which in this case is, where is it? 3.5. And then the estimate assembly time to complete assembly with the actual part, so the total assembly time. Okay, so this gives you an efficiency index based on the time. But you're going to see that it makes sense to do this, so then you have an idea. But you're going to see in for the major effect of this consideration of reducing the number of operation ship will affect the value stream mapping, which is something that you will see in module 2 if you be interested in look at the manufacturing system perspective. So you might see how you're going to identify, as I mentioned, the value added and no add value added to each manufacturing process. But yeah, at this stage, that's at the product level to see the assembly efficiency. You're gonna use this one. And then you have this in there. So that might be, so give you some hints, and then the link would be from the results of the B through to the link would be why you're going to map the process. Not sure if you want to still have the fish plate, but then the consequence will be to apply the value stream mapping. Have you ever heard before the value stream mapping? It's a lean tool for mapping the processes. Yeah.
Practiced it before. Like I said, we've done like some overall processes looking at the pipe shop, doing value added, non-value added, and also waste, because there were some value added, non-value added activities that need to be done to set up your value added and things, but done reductions and stuff like that.
Yeah, brilliant. So yeah, that would be the consequences of the, of the B through. So then you're gonna value stream mapping, and then you're gonna identify where are the wastes in terms of no add value, and then the Lean Six Sigma is how to improve not the existing add value. So if you have a sum of time which is considered as the sum of the all value added, which is the cycle time, plus the no add value, which is all the time for waste, time for transport, time for setup, and etc. There will given the lead time. If you are going to reduce the add value, so lean means to reduce the no add value, not reduce the add value, even if the results might appear improvement. But anyway, that's another story. But it's interesting how to link the product to the process. Okay, any other comments? Do you want to have a look at? So this was the new design. So we see that is much more efficient. And then we review, apart the 3 methods, what are also the consideration that came out also from the case study. So it's standardized part. So the two fish plates, of course, they might lead to some thought to standardized part. Reduce the number of parts, which is not really applicable in our case. Reduction of number of process. So that means which might be a consequences of a reduction of part, but we also mentioned they are connected, but the reduction number of processes is also in our case of the fish plate, reduction of the operation on ship. Orientation. Any comments on the orientation? We haven't talked about orientation for our assembly. Is there any consideration for the any critical orientation?
I suppose just that with the difference in the two fish plate designs, one can be installed in either direction, and one has to be installed in a particular direction. Because the stiffeners are on one side of one of the fish plate designs, but they're kind of symmetrical on the other one.
Yeah. And then orientation is only also a look at in the Lucas method, so for each part. But globally, it would be interesting to look at the orientation if as a penalty, if affect in the penalty score. Access and visibility. Is there any particular difficulty in access? It would be, so how the access to the ship is there any particular fixture to allow the operator to work on the ship? I think they are part of, not all the method, but of the guidelines, which might affect the assembly time. So how the operator works on the ship? I assume in the shop he has his own workbench, whatever, but on ship or how the access? So it might be interesting to look at this as well. I'm just thinking, any comments?
Access can be limited by what's going on like around you, so there's probably enough access for two people to get into the space that's shown. But if you've got scaffolding up, if you've got anything like that could hinder you.
Yeah, it's Louise said, this kind of, I think this is one of the main problems in shipbuilding, is this becomes a very individual, not just to the individual fish plate as to what's installed round about it, but at that specific time, what other work is going on round about you. And this is probably one of the major issues facing shipbuilding.
Yeah. Yeah, correct, makes sense. And assembly from the top, and then manual time consuming, so reducing the locating alignment operation. So locating alignment is another of the score or penalty for the Lucas method. So those are other comments to look at based on the method and based on the analysis of the sequence of operation. Okay, then what else? Yeah, we already said that. Yeah, we mentioned this as well. We comment. Do you have any other question? There is anything else?
Well, for me, that's helped. Thanks.
Yeah, that's great. That helps us. And just make sure you're doing the right way to produce something. That's fine.
Okay, so Yeah, so I'll stop sharing if you don't have any comment, because I think we went through these comments as well. Where is stop sharing? Oh, thanks, Bill. I just got your email. Any other comments? So I think now is more focus on particular aspect, and then I think the next step is to make sure that is a clear picture of the current state. So so ideally, when you complete your current state, it would be also good to bullet point what might be the future state as a. So based on the current analysis, what are you're gonna mention what are the problem from the current state in terms of efficiency, in terms of time, in terms of design, in terms of communication, of missing information. So, and then you can then draw in a little bit of picture what might be the future state, and then you apply the method again, and you remap the future state, and then you can draw in the lesson learned of what might be in the future, the new configuration of the assembly. Okay. Any comments? Is everything clear? So what might be the next step? So I will give you feedback on the Moodle page from the current state, and then so anything can be, you can communicate, put also comments on the Moodle page, so you can interact on the Moodle page, or you can email me. I will open a forum, so then we can use the forum also to discuss with the other teammate, and so then everything might be open to the other one as well. So create a common platform. The query that you mentioned, you might put in the forum, and then other groups might respond, because as has happened today in this active learning group. So some groups have some queries, and then other one, based on their experience or different source, they complete the missing information. There are still something that to clarify. But if there is no, the most important things that need to clarify is the full bill of material, and then the sequence of operation. Then any consideration of the drawing consistency, then you can also only flag up. Then you can focus on your independent analysis using the methods. Is that okay?
Yep, no problem.
Yep.
Okay, guys, if you don't have any other questions, I think we have finished here. So and then I will give you my feedback on the Moodle page, on the open page, as soon as the other group upload the current state. Okay.
Yep.
All right, guys. So
thank you very much, then.
Thank you very much.
Good.
I will
Thank
be
you.
in touch via email anytime if you need anything, and I will open on Moodle page, open also a forum. So I will start putting something, so then you can see if it might be useful or not. All right.
Okay.
Thank you.
Okay.
Thank you.
Thank you very much.
Thank you, Adelaide.
Cheers.
Have a
Bye.
lovely day.
Cheers.
You too.